can see here, and some of the ones that we just saw, on all of these different things. So you can fix your tools, or you can fix the PE file in order to make them load all of these crazy malware-packed PE files. So now, looking a little bit into the signatures, I created a new module that is bundled together with PE file, which is called PE utils. And I just to kind of abstract a little bit the signature parsing. So you will be just loading this file and then just throwing your PE instances to it, and it will just give you the matches back. The cool thing is that you just give it the path, and the path can be a path in your disk, and actually it can be a URL where to fetch the signatures from. So you could just load it from the net, and that's our idea with OpenRC. We want to actually put that together so that we have a live feed of signatures, so people can just upload them, and they will be automatically included. And or you can just pass it raw data, and it will be parsed as signatures. And then the matching is as easy as just passing the PE file instance and saying match. And then it will just return whatever results for that specific file. And then I have some pretty pictures of it running on my collection at home. I think I have around 50,000 pieces of malware, just for fun. And so in this case, I have 53% of those files. There was no packer that was recognized on them. But in the other 46%, I had all kind of them. So that's fairly nice for having an automated tool just running for a couple of hours. You have 20,000 files that you are recognized, and you can actually, then this will be the breakdown for all of them with all the different packers. UPX is the most used one, as probably anybody that has been playing with malware kind of gets the hint, and which is funny because it's kind of one of the simplest, but still super popular. And then there is a good amount of all others. This is a statistic. I wouldn't take it as anything super reliable or representative of the whole malware world, because I don't have such a big collection. It's still some of the trends. The fact that UPX is the most used seems to be corroborated by other sources. And then you get all the other guys here. P Compact, ISPAC, FSG, all the household names. And just to show it another way, you can see here the distribution. So still 17% of all packed files still were recognized as others. So there is a really long tail of crazy ass packers that are used in specific cases. Those tend to be the most interesting ones, because they're the ones that have very crazy features. Temida, Enigma. So these will be the less frequently used ones. And thus, you need to be good or have an understanding what you're doing, which is not always the case, in order to know that this packer is good. I'm going to use this one. That's why UPX shows up there. Most people don't. Oh, a packer. Let's look for something. Oh, UPX. That's cool. And it's not all that difficult to unpack. So now, just a couple of slides on PyDASM. PyDASM just ties really well with pfile. It's a Python disassembler. It's a wrapper I wrote over JT's libdasm, and it's fun. It's cool. It's just a couple. It's really tiny. It's just a couple of methods, and but it allows you to do really interesting stuff. And there was a talk today. I don't know. Some of you might have seen it by Cody Priest from Tipping Point. He wrote a whole CPU emulator based on it and on pfile, and so. Fairly interesting, and and really powerful. You can push it pretty far. So just quickly going through it, this will be the way. You just import it, get instruction, print the result, and you can just process more complex ones. Again, two-liners. That's pretty cool. Again, you can take it a bit further and do something combined with pfile that actually disassembles code at the entry point. And end up, for instance, getting with this, it will be the entry point of Notepad. So, like 10 lines, and you start getting something that looks like a disassembler. So I plan to take this further one of these days and build a proper disassembler, but give me time. So I want to go through a couple of the other things, other topics. So I'm going to rush it a little bit. IDA to SQL is this IDA to SQL exporter. We wrote it for Bitnami, but it's open source, so you can actually just download that separately. It will support most of the information, not data, but all the code references, all the control flow functions, yada yada. And so you can store all your malware collection in a SQL database and then do really funny data mining on it. And PyMay will use a pretty similar database schema, so hopefully most of these tools will eventually become, kind of standardized some way. So this is the schema. So it has tables for all the functions, basic blocks, the expressions, instructions, so all the jazz. This is documented in some blog post I did one night that I couldn't sleep, I guess. So just going to show some of the things you can do with it really quickly. That you can do in-degree, out-degree plots, for instance, with that SQL statement. And so just run this on a couple of files. And the results will be this. And so you could get some sort of idea of certain properties of the graph of those pieces of malware. So another thing I did, and this was just one morning, I was playing with it to see what I could figure out, mnemonic histograms. Again, a single SQL statement, and you get pretty pictures like this, which actually characterize to some extent that piece of malware. And then I thought, okay, I'm going to tie these two things, put them in like a humongous dimensional vector, and use the mathematics clustering functionality. And I actually got some sort of, well, probably you cannot read that, but it's really good. It actually, all the MyDooms and all the different families are kind of together. This is not as good as what we do with VX Class, which is my next topic. But still, just, for a morning hack, just putting together different, metrics of the pieces of malware, you got some, I got some clustering that actually looks kind of half good. But now, for the good stuff, VX Class is the thing that we have been working in Sabre for the last quite a while, way too long. And it's an automated way of classifying malware. It actually uses the MinDiff engine in order to tell the similarities between the pieces of malware. And that's really advanced and produces really good results. So the basic structure of VX Class, it has a web interface and XML-RPC interface, so you can actually automate this process and throw your pieces of malware to it. It has an unpacking module, analysis, and a classification module. He's going to talk a little bit about them. The VX Class Unpacker relies on Box, which is an open source project. I wrote a full Python instrumentation for it, so all the unpacking heuristics are built on Python on top of Box. And this is actually fairly advanced. And works for a fairly good amount of cases. We still don't have really good statistics, but we have thrown collections of thousands of samples, and they get unpacked and classified really well. And the unpacker always is pretty successful. Not always. I know there are really some things that we can handle, but still. So I'm just going to skip this. These are just funky graphics that I did with Box, depicting some packers unpacking, but I'm kind of running tight on time. So this will be just how the unpacker goes on its way until it reaches the entry point. So you will see the unpacker as it processes as it goes about the unpacking process on memory. So the actual analysis and classification happens in IDA, and it's wrapped around like millions of lines of Python. That's way too many. And IDA Python. And so we had to wrap the whole thing and automate it, made it run in batch mode, and actually run BinDiff as well in batch mode. We use it actually because we own it. We built a really nice batch mode module for it. So we can automate all of the process of analysis and matching and finding the differences. And the two interfaces, the one I just mentioned, the XML-RPC interface, allows you to send files for classification or unpacking only, download the IDBs of the unpacked file, and retrieve classification information. So you can get the trees of families and relationships between them. And you can actually rename it through the web interface. So once you have classified like a whole bot family, you can actually just rename one of them and the whole family gets renamed without having to even look at any assembly code of one of them. And then there is a web interface that I will just discuss after this, but this will be the basic methods, and some of them in the XML-RPC interface. So you will just like send stuff, and you can then get all the different classifications, families, yada yada, that are found automatically. Yeah, that looks a little bit. Anyway, this will be the web interface. It just allows you to upload files, set up different options, whether you want VX Class to unpack it or classify it, and then some administration things. And then let's see if we can actually see some of the results. This will be the VX Class working. In this window, it lists statistics about the current status of the different items that you sent, whether they are already classified or they are being processed or unpacked or being analyzed. And it gives you different, metrics or how long it took to do each of the steps. And this is one of the classification windows where it shows the families. The names of the families can be changed. By default, we choose the hash of the representative of that family. And it will tell you how many files are found to belong to that family. And then it has the cooler graphical interface to the family representation, which should come now, which is a Java-based applet where you can browse all the tree relationships between the families. And another way of displaying it. Just if you would get it out of the database and display it yourself, this is how it would look like. So you can actually do fairly advanced stuff. I think I just got it more or less on time. So if you have any questions, feel free. I have T-shirts here of OpenRC and VxClass, so please feel free to. I mean, I kept you here this long, so at least, I can contribute that back. So I hope you enjoyed it. Thank you.